This presentation is going to give you some more information about the chain rule, specifically about given a numerical or graphical representation. Just some formulas for review. So far we have the product rule, the quotient rule, and now the chain rule. I've written the formal definition of the chain rule here at the bottom of the screen. If you don't have it written down somewhere, you really should record it soon. Keep in mind, the whole idea of the chain rule is that we're going to take the derivative of the outer function, which in the rule is f, and then multiply it by the derivative of the inner function. Here it's g. That's where the g prime is coming from at the end. Before we get started, let's go ahead and review some things we did on the last problem set with numerical and graphical representation. This is all referring to a worksheet that you have in your packet. What I'd like you to do is to try number 6, 7, and 10. All of them refer to the graph you see in the upper right-hand corner. It's also on your worksheet if you have it with you. Go ahead and push pause, try the problems, and then as soon as you're ready, go ahead and play it again. You can, fast forward ahead if you want to check your answers. If you're right, just keep going. If you're wrong, then you'll want to listen to me explain each one of those problems. Okay, push pause now. Check your solutions with mine. You should have gotten 2, 7, and 13/25 for these problems. Notice how all of them you're using that notation that we talked about for derivatives. Number 7 and 10, I went ahead and put the u and v's over to the side just because they use the same ones. So that made it nice for the actual derivatives. I want to give some examples of the general power rule. We'll use the same chart here. Let's look at number 8 as an example. Here d of x equals 1 over g of x. You could do a quotient rule, but I'd like to show you an example of an alternative method. What I'm going to do is actually convert this into a power rule. And to do that, I'll bring g of x to the numerator. Now it has a -1 power. According to the general power rule that we learned with the chain rule, the power comes down in front. I subtract 1 from the exponent, and then multiply by the derivative of the inside. I don't know what g of x is, but I do know that its derivative is notated by g prime. Since I have to evaluate this with numbers, I'm going to clean it up and make it simplified by putting g of x squared in the denominator. The point that I'm working with here is 1. So I'll have negative g prime of 1 in the numerator, all over g of 1 squared in the denominator. Those values are in the chart. So this one is equivalent to 1/3. Again, this is the general power rule. The next one is also a power rule. I'm going to rewrite this as f of x to the 1/2 power. So the general power rule says that the 1/2 comes down in front. I'm going to subtract 1 from the exponent and then multiply by the derivative of the inside. Now once again, I don't know what f is, but I know its notation for the derivative is f prime. Okay, let's clean this one up as well. F prime on top, and 2 times the square root of f of x in the denominator. To finish this, I'm going to find this derivative at the point 3. Those values are in the chart. And there we have it, 2 over root 10. The general power rule. Okay, now let's look at the more basic general rule. So instead of that specific application of a quantity being raised to a power, this is just a generic f of g of x. We're going to go back to the basic definition of the chain rule. I can tell this isn't a product rule just because I don't see f times g. It's f of g. So here the derivative would be the derivative of the outside times the derivative of the inside, which we refer to as g prime of x. I want m prime of 1. This is a complex simplification, so let's take a look at what needs to be done. In composition of functions, we're always doing the innermost parentheses first, so I need to evaluate g of 1 before anything else. G of 1 in this chart is 3. So what happens now is I have two separate values to evaluate, f prime of 3 and g prime of 1. So this answer is negative 12. This formula is extremely important for you to make use of and to memorize. Here's another one that you'll see in the problem set that we'll work on for this section. It doesn't look like a chain rule because you can't see the letters g of x, but there is a function inside. Here, g of x is really x cubed. So I'm going to use the same chain rule. It's the derivative of the outside, which is f prime of x cubed, times the derivative of the inside, 3x squared. Just so happens in this problem, I actually know what the value of g of x is equal to. Okay, I want p prime of 1. All right, so I'm really finding in the chart f prime of 1 times 3 times 1, or times 3. The chart says that f prime of 1 is 2, so this answer is 6. These last two refer to examples that we did in the last section in the product and quotient rule. I scratched out the ones that we already did, so we're going to look at the new parts. In this one, instead of being given a chart, the numerical representation is just in a list. You should be able to do both. So again, f of x is little f of g of x. Its derivative should be f prime of g of x times the derivative of the inside. There's that formula again. I'm looking specifically at the number 2. So I want f prime of g of 2 times g prime of 2. Now we're going to have to go to the innermost part first to simplify. G of 2 in this list is 5. That was right here. F prime of 5 is 11. And G prime of 2 is 4. Which means the answer is 44. There's a lot more numbers up there in the given information, but I don't need all of them. Last problem is an example of the chain rule with a graphical representation. This is also referring to a problem that we've already seen. I scratched out the ones that we already did in the last presentation. This time we're going to find c prime of 2, where c is equal to f of g of x, a composition of functions. That means its derivative is going to be f prime of g of x times the derivative of the inside. There it is again. All right, c prime of 2 is equal to f prime of g of 2 times g prime of 2. Okay, going to the innermost parts first. I want to find g of 2. That refers to a y-coordinate on the g graph at x equals 2. That's right there. Let me count. 1, 2, 3, 4. Okay, the last two are derivatives. That means the slope of the curve at those points. F prime of 4 is the slope here. Looks like that's about up 3 over 1. The next number I need is g prime of 2. So I'm back at this point again, but this time I want the slope there. This one looks like I have to go about up 2 over 1, or 2. So this derivative is 6. Your problem set will have problems like this as well as some review problems from product and quotient rule. So look at what's given. And anytime you see a composition of functions, use the chain rule. It attaches the derivative of the inside on the end of the problem.